Welcome, everyone. I'm excited to kick off today's presentation with the fascinating topic of unveiling the digital brain, understanding computer software. Today, we'll explore what computer software really is, how it powers our devices, and why it's so essential in our digital world. So let's get started and uncover the mysteries behind the digital brain that drives our technology. Let's take a closer look at the software ecosystem through a simple analogy. Think of utility software as the system's helping hand, those programs that keep your computer running smoothly, like antivirus tools or file management systems. Moving up, system software acts as the conductor of the computer orchestra, coordinating all the hardware and software components to work harmoniously. Then we have development software, which is like building the future, tools such as compilers and IDEs that allow developers to create new applications and innovate. Application software, on the other hand, is what we use every day, those tools for every task, from word processing to browsing the internet. These components form two main pillars in the software world: system software and application software. Understanding this structure helps us see how different types of software work together to deliver a seamless computing experience. Let's take a closer look at the two main pillars of software today: system software and application software. These are the fundamental categories that help us understand how computers function and how we interact with them. System software is the backbone of any computer system. It's responsible for managing hardware resources and providing the basic environment for other software to run. Think of it as the operating system, device drivers, and utility programs that keep everything running smoothly behind the scenes. On the other hand, application software is what we use every day, like word processors, web browsers, or games. These are programs designed to help us perform specific tasks. They rely on the system software to operate, but are focused on providing a user-friendly experience for particular needs. Connecting this to the overall theme of the presentation, understanding these two pillars helps us appreciate how different layers of software work together. The system software provides the foundation, and the application software builds on top of that foundation to deliver the tools and functionalities we depend on daily. So, at its core, computer software can be broadly divided into two main categories: system software and application software. These two types of software are actually designed to work together, creating a complete and functional computing environment. Think of system software as the foundation of a building. It provides the essential infrastructure that allows everything else to run smoothly. On the other hand, application software is what directly serves the user's needs, like word processors, web browsers, or games. The key idea here is that system software forms the base layer, handling tasks like managing hardware and system resources, while application software sits on top, enabling us to perform specific tasks. Understanding this distinction helps us see how computers operate seamlessly, with these two pillars supporting each other. As we progress through this presentation, keep in mind how these categories connect to the overall functioning and utility of computers in everyday life. Now, let's look at some of the tools users rely on to accomplish specific tasks on a computer. First up is application software. This is what most people use every day, like word processors, web browsers, or games. These programs help us do particular jobs easily and efficiently. Next, we have system software. Think of this as the operating instructions for the computer itself. It's what makes the hardware work smoothly and allows other software to run properly. Without system software, the application programs wouldn't be able to perform their tasks. Connecting these ideas to our overall theme, understanding these tools helps us better navigate and utilize computers effectively. Application software helps us get things done, while system software ensures the entire system functions seamlessly behind the scenes. System software, the computer's conductor. Think of system software as the conductor of an orchestra, guiding all the different parts of the computer to work harmoniously. It's responsible for managing hardware resources, like the CPU, memory, and storage devices, so that everything runs smoothly. At the core of this is the operating system, which acts as the main coordinator, handling tasks such as running applications, managing files, and controlling peripherals. Without system software, the hardware would be like an unorganized set of instruments, difficult to use and inefficient. So, in essence, system software ensures that the hardware and software work together seamlessly, making our computers user-friendly and reliable. System software is the crucial layer that manages and controls the computer hardware. Think of it as a vital intermediary between the raw components inside your computer and the applications you use every day. Without this layer, your computer would just be an inert collection of parts, unable to do even the simplest tasks. It's what makes everything run smoothly behind the scenes. When we talk about system software, we're really referring to the conductor of the computer, coordinating all the hardware and making sure everything works together seamlessly. This is fundamental to understanding how computers operate efficiently and reliably. So, as we continue, keep in mind that without system software, even the most powerful hardware would be useless. Now, let's talk about device drivers. These are small programs that play a crucial role in our computer systems. They act as the bridge between the operating system and specific hardware devices like printers, graphics cards, or input devices such as keyboards and mice. Without these drivers, the OS wouldn't be able to communicate effectively with hardware, making devices unusable or limited in functionality. Moving on, the device drivers are actually at the heart of system software. They manage essential resources like memory, processor time, and peripherals. Think of them as the managers ensuring that each hardware component gets what it needs to function properly without interfering with others. Some common examples include the drivers that come with Windows, macOS, or Linux. These operating systems include a variety of drivers that help ensure your devices work seamlessly with your system. Finally, it's important to see how this fits into the bigger picture. The operating system, or OS, is the core software that manages all of these components, from hardware to software applications. Device drivers are a key part of that management, allowing the OS to control hardware efficiently and reliably. This interconnected system is what enables our computers to operate smoothly and perform complex tasks effortlessly. Let's take a closer look at some of the most popular operating systems today. Starting with Linux, it's known for being open source and highly customizable. This means anyone can modify and adapt it to suit their needs, making it a favorite among developers and tech enthusiasts. Moving on to macOS, Apple's operating system. It's renowned for its user-friendly interface, which offers a smooth and intuitive experience for users, especially those already in the Apple ecosystem. Then we have Android, which powers billions of mobile devices worldwide. Its flexibility and wide device compatibility have made it the dominant OS for smartphones and tablets. Finally, Windows remains the leader in personal computing. Its widespread use, vast software support, and familiar interface make it the go-to choice for many users. Think of the operating system as the traffic cop of your computer. It ensures everything runs smoothly and efficiently by managing resources, applications, and hardware. It's the core system software that starts up when you turn on your computer and keeps everything functioning properly behind the scenes. Without it, your computer wouldn't be able to operate effectively. Now let's talk about application software, which really acts as the tools for every task we need to accomplish. Think of these tools as the practical side of technology, software designed to help us work more efficiently, whether it's creating documents, managing data, or communicating with others. Each type of application software is tailored to specific needs, making it easier for us to perform our jobs or personal tasks effectively. For example, word processors help us write and edit documents. Spreadsheets assist in organizing data and performing calculations, and presentation programs enable us to create compelling visual stories. These tools are essential because they connect directly to the overall theme of how technology simplifies complex tasks and enhances productivity. Without application software, many of the digital functions we rely on daily would be much more difficult or even impossible. So, understanding these tools is key to grasping how technology supports us across all areas of work and life. Application software, often simply called apps, are programs designed specifically to help users perform particular tasks or activities. These are the programs you directly interact with on a daily basis, whether you're creating documents, browsing the web, playing games, or editing photos. They're built to make these activities easier and more efficient. It's important to remember that these apps rely on the underlying system software, like your operating system, to function properly. So, without the system software, these applications wouldn't be able to run or deliver their full capabilities. This slide really highlights how application software serves as the tools for every task we need to accomplish on our devices, emphasizing their importance in our digital lives and how they connect to the overall technology ecosystem. Now, let's talk about broadly useful tools like word processors, spreadsheets, and web browsers. These are examples of software that can be applied across many different domains and tasks. They are considered general-purpose software because they serve a wide range of functions rather than being specialized for a specific job. For instance, a word processor isn't just for writing letters. It can be used for reports, resumes, or even creative writing. Spreadsheets help with data analysis, budgeting, or project planning. And web browsers are essential for accessing information, research, communication, and much more. These tools are fundamental in our daily work and personal activities, helping us be more efficient and versatile. They are key components of general-purpose software, making them invaluable across various industries and contexts, and they really exemplify how software can support a broad range of needs. Now, let's look at how tailored solutions can address specific industry needs. For example, payroll systems are customized to handle the unique payroll processes of different organizations, ensuring accuracy and compliance. Similarly, hospital management software is designed to streamline patient records, appointments, and billing, helping healthcare providers operate more efficiently. Another example is railway reservation software, which is tailored to manage complex booking systems, seat allocations, and scheduling. These specialized solutions demonstrate how software can be adapted to meet the distinct requirements of various industries or functions. This customization is essential because it allows organizations to optimize their workflows and improve overall service delivery. It ties into our broader theme of how software solutions are not one-size-fits-all, but can be specifically designed to create real value in different contexts. Now, let's talk about accessing the vast world of the internet. Web browsers are our gateways to countless resources, information, and entertainment. They allow us to explore, research, and connect with others seamlessly. Moving on, when it comes to creating engaging presentations, MS PowerPoint is an essential tool. It helps us craft visually appealing slides that communicate our ideas effectively. For data analysis and calculations, MS Excel is incredibly powerful. It enables us to organize data, perform complex calculations, and visualize information clearly. When we need to create and edit text documents, MS Word is our go-to application. It provides versatile tools for writing, formatting, and editing all kinds of documents efficiently. All these applications are indispensable for our daily digital life. They offer versatile tools that support communication, productivity, and easy access to information. Because of their widespread use, they've become household names and form the backbone of both personal and professional computing. Ultimately, these general-purpose applications are the everyday essentials that help us navigate and make the most of our digital world. Now, moving on to some specific purpose applications, let's look at payroll systems. These are essential tools for managing employee salaries, taxes, and benefits efficiently. They help organizations stay compliant with regulations and ensure timely payments. In the healthcare sector, we have hospital management systems. These are vital for keeping track of patient records, scheduling appointments, and handling billing processes. They streamline operations and improve patient care. What's important to notice here is that unlike general-purpose software, these specific-purpose applications are designed to meet the unique needs of particular industries or functions. They address complex operations, boost efficiency, and provide targeted solutions. By tailoring software to specific requirements, organizations can optimize performance and focus on what truly matters within their sector. This is a key part of how technology supports specialized industries and improves overall effectiveness. Utility software, the system's helping hand. 4. When we talk about utility software, we're referring to the tools that help maintain, analyze, and optimize our computer systems. These programs act as the system's helping hand, ensuring everything runs smoothly behind the scenes. For example, antivirus programs protect us from malware, while disk cleanup tools free up space and improve performance. Backup software makes sure our important data is safe in case of unexpected issues. These utilities are essential because they support the core functions of our computers, making sure they stay efficient and secure. Understanding utility software is key to maintaining healthy and reliable systems, which ties right into the overall theme of keeping technology running seamlessly. Let's talk about some essential tools that help keep your computer safe and running smoothly. First, creating copies of your data through backup tools is crucial. This way, if anything happens and your data is lost, you have a backup to restore from. It's like having a safety net in place. Next, we have disk cleaners. These tools remove unnecessary files that clutter up your storage space. By cleaning out junk files, your computer can operate more efficiently and quickly. Then there's antivirus software. This is your shield against malicious software and online threats. It scans and protects your system, helping prevent infections that could compromise your data or performance. Finally, I want to emphasize the role of utility software. Think of it as the operating system's helpful assistant. It performs routine maintenance tasks, provides useful tools, and ensures your computer runs smoothly, securely, and efficiently. While these tools might not be involved in the core operations, they are absolutely vital for maintaining system health and enhancing your overall user experience. All of these tools work together to keep your computer safe, clean, and performing at its best. Development software, building the future. 5. When we talk about development software, we're really referring to the tools and platforms that enable us to create innovative solutions. These tools are the backbone of modern technology, allowing developers to build everything from simple apps to complex systems. What's exciting is how these tools are evolving rapidly, making development faster, more efficient, and more accessible than ever before. They help us turn ideas into reality, and in doing so, they shape the future of technology itself. So, understanding these development platforms is key to grasping how we're able to innovate and push the boundaries of what's possible. This ties directly into our overall theme of building the future, because the right development tools are what empower us to create that future today. Sure, here's the word-by-word narrative script for slide 19. When it comes to developing software, having the right tools is essential. That's why comprehensive platforms for coding, testing, and debugging play such a crucial role. Let's start with integrated development environments, or IDEs. These are all-in-one environments that help us write code more efficiently by providing features like syntax highlighting, code completion, and easy navigation through our projects. They also help us identify and fix errors in our code quickly, which brings us to debuggers. Debuggers are powerful tools that let us step through our code line by line, watch variables, and understand exactly where things might be going wrong. Then we have compilers, which translate our high-level human-readable code into machine code that computers can understand and execute. This translation process is vital because it bridges the gap between what we write and what the machine actually runs. Overall, development software encompasses all these tools, IDEs, debuggers, compilers, that programmers and software engineers rely on daily. They're the backbone of the software industry, enabling us to create everything from simple applications to sophisticated operating systems. In essence, these platforms are building the future of technology, making development faster, more reliable, and more innovative. Let's take a moment to explore the software ecosystem through a simple analogy. Imagine it like a bustling city. Just as a city has different neighborhoods, roads, and services that work together seamlessly, a software ecosystem consists of various applications, platforms, and tools that interact and support each other. This interconnected environment is crucial because it allows us to build more powerful, flexible, and scalable solutions. By understanding this analogy, we can better grasp how different software components fit together to create a cohesive and efficient system, which ties directly into the overall theme of how technology integrates into our work and daily lives. Let's take a closer look at the software ecosystem with this final slide. First, we have the game designers and their tools. These are the creators behind new games and updates to existing ones, constantly innovating and improving the gaming experience. Next, we have the application software. These are the specific games you play, like MS Paint or your web browser. They offer unique experiences and serve different tasks to keep us engaged and productive. Then there's utility software. Think of these as the tools that keep your game system running smoothly, like antivirus programs or disk defragmenters. They ensure your device performs at its best. Lastly, we have the system software, which is like the rules of the game and the referee, namely, the operating system. It sets the foundation for everything else and makes sure all parts work together fairly and efficiently. To really understand these roles, it helps to think of the entire software ecosystem as a simple analogy. Just like in a game, each part has its unique role, but they all work together to create a seamless experience.